Namaste. The notes today are on linear inequalities. And if we think about linear equations, those were graphs of lines, and the solutions to those linear equations, like y equals 2x plus 4, if we graph the y-intercept, we know the slope is 2, we know the y-intercept is 4, and we find several of these solutions I've listed here. These are solutions because they're x's and y's that if you plug into the equation, you get a true statement. All right, so therefore it's a solution. And in a linear equality, they all lined up, all right, and formed a line. It went on forever. If it is not an equality, if it's a linear inequality, now we want the y's that are less than 2x plus 4. So if we put negative 2 in for x, okay, 2 times negative 2 would be negative 4. Negative 4 plus 4 is 0. So as long as the y is less than 0, all right, we have a true statement. All right, can the y be equal to 0? Well, no. So for negative 2 for x, 0 is not a solution. So what we should do is we should actually erase that point. All right. So if we get rid of, let me do this. If I get rid of my line, okay, because it's not equal to the ones that were equal to, which was that line, we need to represent that somehow. If we think back to on the number line, right, if I said x is less than 4 on the number line, we would represent that with an empty circle and then shaded to the left, meaning that that 4 was not a solution, but everything to the left of that was. Okay? Well, we can't draw an empty line, so what we're going to do is we represent that if it's not equal to the points on this line, we represent that with a dotted line. It's essentially like the open or empty circle. But again, so if I said y has to be less than 0 when x is negative 2 up here, so negative 1, that would be a solution. Negative 2, negative 1, we here. Or negative 2, negative 2. That's still y. That's still a y that's less than 0. So negative 2, negative 2. Negative 2, negative 3. What if x was something else? What if x was 5? So now this is, instead of 2 times x, it becomes 2 times 5. 10 plus 4 is y's got to be less than 14. So when x is 5, 1, 2, 3, 4, 5, y has to be, and you can see that 5, 14 would be a continuation of this line, as long as y is less than 14, which would be anything here, or here, or here, or here. Any of these points down here. And as you can kind of see or imagine, actually anything that's over here on this side of that dotted line, anything over here will actually make a true statement. So what we do is we have the dotted line and then we shade this side, okay? Obviously we're not going to put a bazillion dots in here. We're just going to shade this side of the line. So everything that's over here on this side of the dotted line is a solution. And in fact, if I picked something on this other side of the line, let's say like 0, 8, which is right here. 0, 8, if you put 0 in for x and 8 in for y, what happens is you get 8 is less than 0 plus 4 is 4. This is not true. All right? So it's not a solution. And in fact, every point over on this side of the line, of the boundary line here, is not a solution, and every point on this side is. So what we're going to find is if it's a linear inequality, the graph gets divided in half. Half of the graph is solution, and half is not. It's not just all the points on the line. And in fact, as we see here, the line itself is not a solution, which is why it's dotted. Right? If I have, let's say that this said y is greater than or equal to x plus 8. Well, that's these two things together. Y equals x plus 8, or y is greater than x plus 8. So this is made up of two parts. The first part is this line that we have graphed and we're now experts at. So y equals x plus 8 has a y-intercept of 8, has a slope of 1, and so it looks like this. That's y equals x plus 8. Now, the other part of it, right, is the greater than part, is we need to figure out where the solutions are. So where are the x's and y's? The easiest way to do this is to figure out, are the solutions down here on this below, or the solutions up here? And so we're going to test a point to see, is it a solution or not? And the easiest point to test would be, I think, 0, 0. So if you put 0 in place of y and 0 in place of x, is it true or false? 0 is greater than 8. That is false, which means at this point, 0, 0, which I just tested, is not a solution. Right? If it's not a solution, then the other side must be. And in fact, everything up here would be a solution. And so this would be the graph. Right? I shade onto this side of the line. Now, this is a solid line again because it's greater than or equal to. So the equal to y equals x plus 8 is part of the solution. So it is a solid line. When it was not, it was a dotted line. All right, so try this one on your own, okay? And then come back and test it. So hit pause and come back. Okay, so again, now I've drawn a dotted line. It's not very good because I didn't really use a ruler, but it's dotted because the actual line itself, y equals negative 3x plus 8, is not part of the solution. So it's dotted line. So number one, is your line dotted or solid? It's solid if you would fill in the circle. In other words, is it equal to? If it's equal to, it's a solid line. If it's not equal to, just greater than or less than, it's a dotted line. And then we're going to test a point. I'm going to test 0, 0 most of the time to see if it's true or false. If it's true, then you shade the side the 0, 0 is on. If it's false, you shade the other side. If you test 0, 0 in here, we get 0 is less than negative 3 times 0, 0 plus 8. 0 is greater than 8. It's still false. So this side that 0, 0 is on is false, which would make the other side true. All right. Probably you're going to want to then just pick a point over here. So pick like, what's this, 1, 2, 3, 4, 4, 1 is right here. So make sure that works. If you put 4 in for x, negative 3 times 4 is negative 12, plus 8, and then 1 for y. Is this true? 1 is greater than, this would be what, negative 4. 1 is greater than negative 4, that's true. So this side over here that 4, 1 is on is all the solutions. All right, same thing here. If it's in standard form, you could rearrange it. I wouldn't. I would just graph the two intercepts. All right, if you cover up y, the x-intercept is negative 4. If you cover up x, the y-intercept is negative 3. Before I draw my line, I consider that it should be dotted because it's not equal. So I kind of come and do a dotted line in here. All right. With the ruler would be best, but it doesn't have to be. And then I'm going to test 0, 0. So 3 times 0 is 0, plus 4 times 0 is 0. Is 0 greater than negative 12. Yes, it is. So this, again, here's where 0, 0 is. The side that 0, 0 is on is where all the solutions are. So I would shade that side. Okay? So that's linear inequalities. Not too bad. You just need to make the decision. All right, so you're going to graph the boundary line, the border, all right, between the solutions and not. Decide, sorry, is the boundary line dotted or solid? All right, and then test a point and shade the side where the solutions are. Okay, thank you. Thanks for listening. Namaste.